next little bit. And Anne, I think I forgot to ask you to introduce yourself. So if you would say a word about yourself, Anne, and then be delighted to have you introduce our speaker.
Thanks, Jill. Welcome, everybody. Ann Canby, probably before many of you were aware, ran Del or tried to back 30 years. And then have been doing a variety of other things, mostly not in Delaware, except for the last few years. So environmental, getting our transportation program to be a little more friendly to things other than driving a car. Anyway, so it's great. So many people here already are aware of John and Ecoplastics. But if you don't know, he's got a long and varied environmental history here, and from many perspectives on the environment, from working with dealing with hazardous materials and a precursor to the Inland Bays program. Who knew? I didn't know anything about that. You must have worked with Till Purnell, maybe.
Yeah, absolutely.
And then put together WIC Associates, which is where I think we finally actually met each other when I was at Del since I wasn't in Delaware before then, and where there was a lot of environmental consulting and helping people get things done right. And then the most favorite thing that you probably may not be aware of, but he did a 4.5-month solo trip in what kind of a boat around the Delmarva Peninsula, just checking out all of what was going on and putting together, I think, a film for the History Museum and others to really help people understand the richness and of that environment, and also the threats it's facing, which are not insignificant. But that wasn't enough to keep him going. So he then got involved with the U.S. Rowing Association. And then after that, got engaged with Ecoplastics several years ago. So he's well prepared to think about this, and has a great background from both advocate, environment, business, the whole 9 yards, to help us think about how we take Ecoplastics to new levels and what the challenges are to getting there. So John, great to have you with us, and thanks for joining us.
All right.
And if I can butt in here with what I forgot to say, is I think we'll hold all the questions till the end. And then when folks have questions at the end, just raise your hand and I will be happy to invite you to speak, and then John can answer. So thank you, John.
All right. Let me see if I can get my screen up now. That's the next challenge. Did that come up for everyone?
Not yet.
Not yet.
No.
Okay, well, that's not working. We had this worked out before we got started, and now it's not. Let me go back here. And see where we are. Folks, bear with me for just a second. Is that screen coming up for you?
No, not yet.
Not yet. Well, that's not working. There you go. Does that give you my screen?
That's it.
Yes.
No.
Got it.
Here we go.
And make it, there we go. That's what I wanted. Okay. So as Anne mentioned, I've been involved with the environmental business in Delaware for quite some time, but we're going to talk about plastic tonight. And I want to focus not just on what we do at Ecoplastics, but I really want to focus on the exploding plastic waste crisis that we have. And basically taking a little bit of a historic view of how we got here, looking at things from billiard balls to an indispensable material to really an environmental crisis. Then I want to talk for a bit about how that plastic material begins to break down in our environment, so that we get a better understanding of what's happening and why it's a problem for us. And then finally, we'll get to ecoplastics and some of the things that we are doing at Ecoplastics. And Dee, I'm going to start right off and say, you and I are not so far apart on this. I agree with you. Single-use plastics need to go away. Recycling is important, and there is definitely a role for recycling in our environment, even if we just look at it from the mining perspective. Let's get started. So we can go back to the 1850s, a little bit before, and we start seeing plastic resins, materials, celluloid coming in. One of the initial uses was developed by John Wesley Hyatt. He was looking for a substitution for ivory billiard balls, of all things. Well, of course, that didn't really work out and wasn't a real big economic driver. So the first real use came in as denture plates, and that was followed by knife handles and ballpoint pens and shirt and collar stays and cuff stays. And eventually we get to Barbie, we get to Legos. As every young dad knows that when you walk across your kid's room, you're going to step on Legos at night. So, if we take a look at the very simplest of modern plastic manufacturing, we begin with, of course, a crude material, crude oil, natural gas, coal, biofuels. We refine it down to a monomer, and then that monomer is turned through polymerization into a long chain polymer. And the ones that we typically look at are polyethylene, polypropylenes. So I did a little bit of research and tried to come up with some high points in the development of plastic, just to give us all a little bit of a perspective on how this world of plastic resin has evolved. In 1916, Rolls-Royce actually began to use plastics in the interiors of their automobiles. We can go down a little bit further. You see DuPont Nylon is there with their patent in 1935. That put DuPont's nylon plant in Seaford on the map, certainly, and Route 13. Then we can go on from there a little bit further. In 42, we had super glue, 49, Tupperware and Lycra, 58, my favorite, Legos, and then Barbie in 59. And then we can go on further and we can see that something very famous happened. And I think most of us remember The Graduate and the famous line by Mr. McGuire, where he basically looked at Benjamin and said, I want to only say one word to you, just one word, plastic. And how right he was from an economic standpoint. Neil Armstrong showed up on the moon and dropped the nylon flag there. And then in 1976, we suddenly see that plastic is outstripping almost every other material in the world as the most recognized and most used product. Think about that development. Very short period of time. In the 70s, late 70s, and the 80s, we begin to recognize that not only is this product growing rapidly, but now we are beginning to get into the plastic waste issue. And we see the first triangular chasing arrows for the plastic recycling. And this was a bit of a corporate push to make sure that the recycling concept got put out on the table. It suggested that big corporations were recognizing that the waste product was going to be a continuing problem. And they tried to push the solution to that back on the public and suggesting to the consumer that, well, it's your responsibility to properly recycle plastic. We get to 2010 and beyond, and we look at things like plastic blood and plastic solar cells, medical grade plastic for implants, 3D printers, driverless cars, any number of other issues. So if we look at this from the graph, you can see that back in 1960, we were producing about 10 million tons per year of plastic. By 2000, we got up to about 200 million tons of plastic. And then we get to 2020 and we're up to about 450. And then as we get on to 2050, we're at 1,470 million tons of plastic are expected to be produced. That's an enormous amount of material. So what does this do to the plastic waste world? Estimates for 2023, worldwide production was at 250 million tons per year. That's about 110 pounds of plastic per person per year, waste plastic. If we look at just the United States, we're looking at 33 million tons per year. And we only recycle or reuse about 7% of that. So let's do a Gedanken experiment. You all remember Einstein with his famous Gedanken experiments. How many pieces of plastic did you come in contact with since you got out of bed this morning to get to this call tonight? Think about it for just a minute. And then think about what is going to happen to them. Where are they going to end up? You begin to quickly realize just what a problem waste plastic is. If we look at major producers of waste plastic, you begin to see the United States very quickly is leading the world in the millions of tons that we are producing compared to everyone else. Now, it wasn't that long ago that China was in the lead, but China had an issue back in 2017, 2018, and they instituted a program called Operation Green Sword. Green Sword essentially took all of the film plastics, or the majority of film plastics, single-use plastics, out of the Chinese economy. They shut that whole process down, and then they limited the amount of waste plastic that they would accept from Europe and the United States. They had been taking a lot of our waste plastic materials with the thought that they were going to recycle and refine them. They recognized this was a problem. They turned around and shipped all of that material, or the bulk of it, down into the Southeast Asian countries. And from there, most of it ended up in the Pacific. It's created that big island of plastic floating around in the Pacific. And we'll speak a little bit more about that in a minute. But they were at about 52 million tons of plastic before Operation Green Sword. And they have been able to reduce their waste plastic dramatically. So in a thumbnail sketch, that's where we are with the amount of plastic that's out in the world right now, waste plastic. And I want to take some time and begin to talk about how that waste plastic breaks down in the environment. And I like to call this the good, the bad, and the ugly, because the good is that we need plastic materials. They are in medical products. They are in our computers, and if we go back to the Gedanken experiment, they're in just about everything you picked up and touched today. So we really can't say that plastic is bad. It has a very important use, and it's really, from my perspective, not something that we can just say we're not going to use any longer. We can certainly eliminate single-use plastics, but overall, we're not going to be able to just shut down the plastic industry. It's bad because those macro pieces of plastic break down in the environment, and they get smaller and smaller and smaller. And as they get to the very small nano stages, they become easily absorbed, they become easily ingested and inhaled. And that's the ugly. So let's begin with the macroplastics. I think most of you are aware at this point that macro waste plastics, about 74 to 94% of them are either landfilled or end up in the environment in one form or another. Only about 7% of them are actually recycled at this point or reused. That's a very small percentage. Going back to Operation Green Sword just for a minute, when China took that step, the amount of plastic waste going into our landfills increased by 23%. And the same applied to Europe. All of their landfills increased equally. Most of our waste, of course, starts out as macro. And, you know, it ends up in our landfills. It goes through degradation, either by tractors or mechanical devices driving over it, or just general mechanical processes in the environment. It goes through photo degradation very easily. UV light breaks down plastic. And then biologicals come in, and bacteria and fungi can also break it down, as well as chemical materials. And it breaks down into the micro, the nano, and the microfibers. Those are small enough that they can actually pass through the filtration systems that might be applied to a landfill or to a wastewater treatment plant, and they can go out into the waste stream. They're also small enough to become inhalants, and as a result, we are breathing in a lot of these. The interesting thing about these smaller particles is that they are multifaceted. That gives them a very large surface area. Unlike say, a BB shot or a grain of rice, they don't have smooth sides. They have fasciated sides, much like a cut diamond. And that gives them a lot of area. These particles typically are negatively charged, slight negative charge. And because of that, they can easily pick up hazardous materials, either some of the plastic chemicals that are used, and there are numerous of those. We know that about 42 of them are toxic. They can easily absorb those hazardous chemicals as well as any other hazardous chemicals. And that allows them to become vectors for contaminants that if you inhale them, they will end up in your system or in any animal system. We can look at not only the plastic chemicals, we can also look at the chemicals that might show up in a landfill or in a wastewater treatment plant. We can also look at biologicals. Many of the biologicals are tend to be a little bit more positive in charge. So they can also adhere and become part of the contamination that these particles can induce in you, either as an inhalant or as an ingestible material. Pretty picture until we look at what the source is. This is just plastic in a landfill. And it's really pretty dramatic when you begin to look at that and think about how much of that material is actually plastic. So what happens with our oceans, rivers, and our bays? According to Oceana, 2020 report, the equivalent of 2 garbage trucks of plastic waste are dumped into the ocean every minute. That's pretty incredible when you think about it. If you begin to look at the accumulation of this material, it's very clear that it is building up. And as a result, if you look at the one statistic there in 2017, 80% of the plastic that was entering the ocean came from the 5 Asian countries. That was primarily as a result of Operation Greensword. And we are looking at this increasing dramatically. In 2024, we're looking at about 15 million metric tons. By 2040, we're looking at about 30 million metric tons. So again, the amount of waste plastic going into the oceans is just dramatic. And it's not just stuff coming from landfills, it's fishing nets, it's material that's thrown directly into the oceans. It's an enormous amount of waste material. The impacts, I'm sure most of you have seen the pictures that came out about the turtle with a straw up its nostril. It's obvious that with all of this material in the oceans that it's being inhaled and ingested. And there's another statistic right there that is rather staggering. And that is that there are roughly 250 pieces of plastic debris in the oceans for every human on Earth. Think about that. It's just an amazing amount of material. These were pristine South Pacific Island beaches. They're no longer. I look at this and I think back to, World War II and what Navy people and Marines and soldiers might have seen on these beaches, and then what are they looking like now? And Dee, I put that in for you.
Got it.
So what about us? What about in our own backyard here? Most of you know that I live in Newcastle, and right down in historic Newcastle. And Beverly, my wife, and I moved here a long time ago, back in 1971. And we used to walk our dogs down along the beach, and we would collect firewood to burn in our fireplace. And I can remember seeing maybe an occasional basketball, maybe an occasional sneaker, maybe a flip-flop. This is the Strand, a section of the Strand in historic Newcastle. This is after a high spring tide. And you can look at the material on the beach there, or on the grassed area. And if we look closer, it is very apparent that the majority of this is plastic and plastic waste. And I guess the question I'd pose to everyone is, how do we clean that up? What do we do to actually clean this material up? Now, if we take the macro world that we just sort of went through with landfills and things, and we begin to break it down, we first go into the micro world of plastic waste, and those are basically particles that are less than about 5 millimeters in size, about the size of an eraser. Mechanical breakdown, UV light, biological breakdowns all contribute to this. There were a whole area of plastics that were produced at one point that were not macro in size. They were in fact micro, and they were the polymer additives to cosmetics and exfoliants. They were essentially little grains of material that were put in these products to help them do their job. For example, toothpaste. You want to use a bit of a grit in toothpaste to take the tartar off your teeth, and that's what they were doing. In 2015, with the Microbead Free Waters Act, at that point in time, it was recognized that this is not a good thing to put into cosmetics or personal care products. So they were actually banned back in 2015. One of the important points about these materials is that they were small enough. In fact, all microplastics begin to get small enough to pass through wastewater treatment plants. So even with polishing in the wastewater treatment plants, many of these materials will go directly into the wastewater stream and out into the bays, rivers, and eventually the oceans. We go down from the micro size down to the nanoplastic wastes. And when we start talking about nanoplastics, we're talking about 1 million, there are 1 million nanometers in a millimeter. So you begin to understand just how small these particles are. They are inhalants for the most part, very easily inhaled because they're literally in all of the air surrounding us. So the other area of the nanofibers or the nanoparticles are the microfiber plastic wastes. These are tiny strands of resins that basically are getting broken off of products that are made with plastic resin. Think of your nylon shirt, think of your waterproof jacket. Every time you brush against something with that, it breaks off tiny little pieces of microplastic waste. And these are at the nano size, and they're literally everywhere. Every time you wash some clothing that has polymers in it, those polymers break off and go into the wastewater stream, which goes off to the wastewater treatment plant. And again, they're so small that they literally pass through the wastewater treatment plant. In 2024, NOAA and EPA issued a joint report, the Interagency Marine Debris Coordinating Committee report, just on microfiber pollution. And interestingly, they came up with a sort of recommendation that these were, in fact, environmental problems and health hazards, but they really didn't have a good understanding of what the hazards that were being created from them were. They didn't know the physical, chemical, or biological effects that these small materials would have on us as humans. Some recent research, bioaccumulation, either from inhalation, ingestion, and absorption. There was one study that came out fairly recently that suggested we as humans are ingesting somewhere around 39,000 to 52,000 particles of microplastic, not nano, but microplastics annually. And if we include inhalants, you're boosting that number to 74,000 to 121,000 particles. And then if you take someone who is just drinking water out of a plastic water bottle to meet their daily requirement, the recommended intake of water, you can add another 90,000 particles to that individual. This is a huge amount of material. It's been suggested it's about the size of a credit card. And other research, again, fairly recent, is suggesting that these are some of the health effects that's on the lower right side of the screen there: oxidative stress, neurotoxicity, reproductive toxicity, carcinogenity, and then altered metabolism. I was reading another report just this morning that was verifying some of these effects from the nanoparticles. This past year, the states, there were 36 of them that actually considered 450 bills, different bills, that were looking at specifically dealing with microplastics as well as PFAS, forever chemicals. And they include phasing out PFAS in textiles and cookingware and cosmetics, reducing the amount of plastic and phasing out plastic chemicals from packaging, and then banning the use of PFAS in wet weather outdoor apparel. I think Gore-Tex is one of the materials that's being considered here. So to get to the case for recycling, many people have suggested that we have to ban plastics and we have to just eliminate them from our environment. And I would go back to, we really are not going to be able to do that. We're using plastic in medical technology and computers and cars. I think it would be very, very difficult to just eliminate it. Single-use plastics, absolutely. We can go back and do a good job of trying to reduce those, as we have begun to do here in Delaware. But if we get back to the idea that if we recycle some of these plastics into more solid forms, simulated wood product, maybe something for decking, maybe something for retaining walls, we're able to bind them up and cut down on the amount of surface area. And by cutting down on the surface area, we can cut down on the formation of micro and nano and microfiber materials. And that, in effect, will help reduce the amount of the ugly materials that would get into our system and into our environment. There are other recycling technologies that are being looked at right now. A couple of the big oil companies, Exxon is one in particular, are looking at the idea of taking and recycling the material down so that it can be used as a pure polymer, and then reintroducing those pure polymer streams back into the usable product lines. There's been a lot of work in this. There were some successes, and then recently I saw some issues with some of the, was the Exxon plant out in Texas. But the other idea with this is that if you don't take it to pure polymers, you're able to take it to a very clean burning diesel type fuel. And since plastic doesn't typically have the sulfur in it, it would actually be a benefit. Okay, so we've gotten through the history and we've gotten through what the problem is. Now let's talk about what we're doing at Ecoplastics. I like to preface this with think globally and act locally. It's an old phrase. We all recognize the importance of it. And in this case, I think it's very true. By working with smaller groups, smaller manufacturing facilities, it's a whole lot easier to take control of waste plastic and do something worthwhile with it. Ecoplastics is a 501c3, as most of you know. We have two different missions, actually. One is to remove waste plastic from our landfills and the oceans and the environment. The other is to create a workplace for individuals with special needs. So we've really focused on doing that, and I think we're doing a pretty good job of it. The company was started about 5 years ago and is based at 18 Germain Drive. Our goals in trying to meet our mission is to produce viable products that we can provide to the local economy that are composed mostly of waste plastics. And then, in addition to providing a product, we're trying to provide technology and guidance for other groups that might want to establish the same kind of a facility. And we think that doing this smaller outreach and smaller manufacturing has got a lot more possibilities than trying to do a major waste recycling business. We've seen attempts at doing that, and the separation technology really holds them back. In this case, we're small enough that we can work through the separation, and with good customers bringing waste materials in that have been properly cleaned, it makes our job a whole lot easier. The third part of our goal here is that we really do want to do education and outreach and let folks know just how big this problem is, and that we really do need to take steps to begin to control it. So I like this picture of our facility in that you don't see the front of it. but you do see the top of it. And the top of it demonstrates the commitment that this group, that the company has toward not just recycling plastic, but towards the environment. We've got a 50 kilowatt solar array on top of the building, and it supports about 90% of our operation. So recycling 101, it's really pretty simple. We collect it, we have folks come in, it gets weighed, and then we take and we chip it, granulate it, shred it, add a color additive, run it through an extrusion machine and mold it into basically simulated wood product. We create benches, we create bicycle racks, we create products that we can then turn around and sell back into the public. If we go a little bit deeper on this, we're collecting about 1,000 pounds of plastic, waste plastic a week. And our sources are many of you sitting right out there. You know, I know Ollie does a lot for us. We also have homeowners who bring in their bags of waste plastic. Schools will contribute. We have school groups that come in and help sort. Libraries are a big source for us. We have a couple of different libraries that collect waste plastic bags and number 2, number 4, and number 5 plastics, and it all gets brought in. When it comes in, we weigh it all. That's the first thing that we do. We keep track of every bit of plastic that comes into our operation. We need to do that because of our permit with the Department of Natural Resources and Environmental Control. DNREC has given us a permit that is very similar to the big waste management companies' permits, except ours is a lot smaller cap than they have. We can only keep 7 tons of material on site at any one time. And that material includes not just the waste plastic that is brought in, it includes all of the waste plastic that is in process. That is the material that's been chipped, the material that is in the hopper being melted down to turn into an extruded board, the boards that are on site, and all of the completed product that are sitting on site before it's shipped out the door. The permit level creates a problem for us in that 7 tons is a number that we reach on a fairly regular basis. And at times we cannot produce product quickly enough to get it off-site and shipped out. So we will have to stop taking waste for sometimes as much as a month. You're all familiar with the different types of plastic. These are the ones that we are particularly interested in, 2, 4, and 5 for most of the extrusion work that we do. So we begin by sorting our plastic by type, by color, by contaminants. If it's too contaminated, if it has not been properly rinsed, or we will have to reject it. And then it goes off to the landfill. Sorting is all done by hand in our operations. And then we take and we chip it. The fluff that you see on the left-hand side of the screen is what it comes out as, is chipped plastic. The 2 right-hand pictures, that's a hopper and one of the extrusion units, and the nozzle in the that you see down at the bottom of the hopper on the right photo is actually where the plastic comes out. So with that, let's take a minute and actually see what this process looks like.
Okay, we're standing here in front of granulator. Once our plastic is separated to different types of plastic, different colors, the first step is to reduce the size of that plastic with this machine called a granulator. All right, so this is the granulator process. You can see one's going up with the buck.
So Juan has just dumped plastic into the granulator, and you're going to see that plastic material coming out down below. We have a bit of a problem here with our video, so I'm just going to narrate over it. Can you hear me? Can you shake your head if you can hear me? Yeah, okay. That's the bottom of the granulator. You can see the chipped plastic falling into the basket. And that chipped plastic is taken and it's moved over to the extrusion machine. We have 2 big extruders. This is the smaller of them. The waste plastic is dumped. The The particles are dumped into the top of the hopper. They're heated up to about 425 degrees, and then they are forced out through a screw extruder, which is that nozzle coming out at the bottom. You can see the plastic just slowly pushing out of there. After the plastic begins to flow, it's cut off with the spatula, and then they attach to that a big mold. There's the mold being attached. In this case, we're talking about a 4x4. This is one of the simulated boards that we used for the DuPont job that I'll talk about in just a minute. After the mold is filled up, it's cooled for a bit on the tray, and then is removed from the tray, moved over to a big water tank in slow motion, mind you. And it's immersed in the water bath for about 10 minutes or so. James is going to remove it from the water tank here. And in about a half minute, they're going to knock that piece of simulated wood right out of the mold. Must have an overload on my system. All right. We're going to finish up with this. So I'm going to talk now a little bit about our products. And I apologize for the video. It somehow or other got garbled. It was working earlier today. This is one of our most recent projects and products. This is 4x4 simulated wood boards that we've used at the DuPont experimental station. DuPont had a need to prevent erosion coming off of this garden area next to building 444. It's one of DuPont's more environmentally conscious buildings. The material was running onto the paved area in front of the simulated wood and causing DuPont to be concerned about slip, trip, and fall hazards. They looked first at putting in a stone wall. They recognized the cost of that would be a little bit excessive. Then they looked at basically treated wood, and they realized they would have maintenance problems with it. So they came to Ecoplastics, and we talked about providing them 4x4 simulated wood boards. And you can see the wall came up, the retaining wall came up very attractive. DuPont was happy enough with this one that they've now asked us to look at doing a 165-foot long wall out of 6x6 simulated wood. And that would be about a 4-board high wall and would use up about 3 tons of plastic. So for us, a big project like that is important. It allows us to get a lot of throughput the facility and keep below our DENREC max. And that allows us to take more plastic from different sources. What's going on? One of our other products, of course, is benches. Many of you have seen our benches. We do both straight benches, colored benches, and then we also can put memorial plaques on them. There are a lot of manufacturing companies that will buy these, or some of the big utility companies, and they'll dedicate them to different county parks and things. And we get into picnic tables. The coloration that you see there is a sample, so you get an idea of the different colors that we can do. All of these are impregnated plastic colors. They are not painted on. You can also do a hexagonal table. And the nice thing about this table is that we can take away one side and make it handicap accessible. Bike racks, parking blocks for parking areas. And of course, lots of simulated wood. We're just right now, we're putting a second extruder online, and we're going to be producing some larger, much larger materials like 6x6s and 10-foot length. So the next question that comes up is, what can you do? And that is collect and recycle clean plastics. Make sure when you bring it in, clean it. That would really help us out if you do that. If you don't bring it to Ecoplastics, take it to an appropriate recycling facility and understand that it's going to be recycled and not just put into a system that's going to get it to end up in a landfill. Talk about this issue. Let folks know that plastic waste is indeed a problem. And then, of course, we'd love to have you come down and volunteer. If you want to donate, we're 501c3. I have to do the advertisement, and you can go to ecoplasticproducts.org. You can see the products that we have in the price list and everything else. And of course, we'd love to have people come in and purchase from us. We've got lots of innovative products. And if you think of a new product, we'd love to have you come in and talk with us about it. With that, I will entertain questions, comments, and discussion. Okay.
Great, John. Very
Jill?
thoughtful and complete. We understand now. It takes a lot of plastic to do that. Jill, you're muted.
Cheryl has a question. Jill, you're muted, but Cheryl has her hand up.
Yeah, go ahead, Cheryl.
Hi, John. It's good to see you. I confess I know John from years ago. My question is there a way for you to seal the plastics, particularly those that you put outside, the boards and stuff, such that the nanoplastics don't come off?
John, now you're muted. John, now you're muted. There you go.
Go. Sorry. The answer, Cheryl, was no. There really is not a way that we can seal them. I suppose someone could try painting them, but you're going to end up painting them with resins anyway. So it's the idea of encapsulating is, I would think, pretty ineffective. But remember, when you block these into big chunks of plastic, you're binding up much of the smaller material that would be breaking down into the nanoplastics, into the microfibers. So you're really enhancing the ability to maintain those structures instead of allowing a small amount to work off on the outside. But you will have small amounts working off on the outside. Think about a plastic drinking bottle. As you drink out of that, there are bits of plastic that you're ingesting.
Well, personally, I haven't drank out of a plastic bottle in years.
Okay, good. Good.
I'm on the board of Plastic Free Delaware with D, so just a full confession there.
Let's take that statement though, and let's break that down a little bit. Do you have any nylon clothing?
Probably not.
Oh, good. Well, that's good. All right, well, there you have it. That's a big reduction in the amount of microfibers that you're going to see. Well, that's good.
I'm probably not a good example. I use silicone baked parchment paper.
So Dave, I think, was that your first question? You mentioned that sunlight degrades plastic. What happens when the plastic wood degrades outdoors? Is that your question?
Yeah.
And then if you want to ask your second question out loud, that would be great.
Well, shall I wait for the answer to the first one? I actually have another meeting. At 7:30. The second.
Can we hear you? Can you speak up a little?
I probably have my hand over the microphone.
There you go.
That's better. Why don't I just say the other question? That I think Indian meal moth larvae are known to actually feed on some plastics. And so I'm wondering, in terms of bioremediation, is there evidence that that any organisms in nature are evolving to feed on and decompose plastics?
Dave, I cannot speak to that specifically, but I can tell you my experience in another very much related field. Back in the 80s, when I owned Wick Associates, and we were doing a lot of oil tank remediation. We were looking for a way to deal with contaminated soil, that is, soil contaminated with oils. And I recognize that if you go out to Santa Barbara, there are natural seeps of oil. And if we see oil spilled in the environment, even on sandy beaches in New Jersey, eventually it seems to go away. And I began to question what happened. And so I did some research with some folks at the university and recognized pretty quickly that there are groups of bacteria that had evolved that could actually digest that carbon source. And then I went down and collected a sample of material from one of the waste pits down at the refinery. And we actually cultured it in my company. And we produced a material, bacteriological, that we could then mix with water, add in some nitrate, add in some phosphate, and you could spread this in a controlled situation on contaminated soil. And we could actually break down the soil or the oil contaminants in the soil pretty quickly. We actually called the material Bugs Plus and sold it all over the country. It was very successful. So the kind of a circular answer to your question, is it possible for bacteria or other biologicals to begin to break down plastic? I would say absolutely. And I think I mentioned in my earlier talk that there are biologicals that are doing that, primarily bacteria and some fungi we're aware of that are beginning to break it down. Question is, do they break it down quickly enough? Do they break it down in large enough groupings so that it really has an impact, number one? And number two, once they break it down, what do they break it down to? Do they just break it down to the nanoplastic size, and then does it go off into the atmosphere as an aerosol? Do they break it down to the nanoplastic size where it goes off as leachate? So if you're looking for a complete solution, I'm not sure that's it. But
Thank you.
Thank you. Ruth Ann, did you ask your question? I'm sorry, I've gotten a little mixed up here.
No, I didn't yet, but thank
Yeah.
you.
Please.
I'm curious, how polluting is the process that you're currently developing? And my second question, and you can, choose one or the other, because I know they're very different questions. I've been working to do some economic development job creation project in a disadvantaged community. I'm wondering, how easy would that be to replicate your existing example, but instead of you working with disadvantaged adults, it would be economically disadvantaged people in a difficult situation, difficult community. Thank you.
Yeah. Let me take the second one first. I think that the kind of operation that we have is not real complicated. There's not a lot of science involved. It's mostly mechanical work. I think it would be great to see this kind of an application in a disadvantaged neighborhood. I think that keeping it small would be a good thing to do. I would certainly want to make sure that if I was going to set something up, and we talk with folks about this, if we wanted to set up another operation or work with someone to set up another operation, we'd want to make sure that any individuals who were working in that operation had the proper protective gear on. When you work a little bit with DuPont, you realize how safety conscious they are. And frankly, when I first started getting involved with ecoplastics, I was a little concerned about some of the safety issues, masking and eye protection, ear protection, toe protection. And we've stepped up our game quite a bit. And I think as you move forward with this process, the game is going to have to be stepped up even further to protect individuals. Does it make sense to take something like this to an economically disadvantaged neighborhood? Yes, absolutely. But there's going to have to be an initial investment in the equipment, and the kind of equipment we're talking about, it's not astronomically expensive, but you're going to end up putting probably $300,000 to $400,000 worth of equipment on the floor. Then you're going to need the building, then you're going to need to set up the marketing on the front end and the marketing on the back end. There's a bit of lead time with this.
Thank you so much.
So on the, oh, Carol, do you have a question?
Actually, I have two. Can you explain the DENREC max?
No.
That's question one.
Okay. I cannot. The only thing I can say is that when the company got started, DENREC came in, and of course the company needed to have a permit. There was a waste facility up in Wilmington that was, I believe, taking tires at the time. And they filled a large area with tires. And as I understand the story, they seemed to walk, and DENREC was left with a situation. Because of that, it's my understanding that DENREC got very careful about its regulations and wanted to make sure that they were able to control what was going on after that incident happened. So they looked at ecoplastics and they realized what ecoplastics was trying to do. And they thought a reasonable max would be 7 tons. We have not gone back to DENREC to ask them to raise the max. And in some ways, I believe we should, but only after we have been able to secure some other large contracts that enable us to do a lot larger throughput than we're doing right now. Throughput in this game is the answer to being successful. If we can produce 6x6s that are 10 feet long for a 165-foot long retaining wall, we've just burned up a lot of waste plastic material, 3 tons just for one project. If you think about all of the bollards, those are those posts that are around driveways in state parks and in county parks. If you think about those are typically 6x6 pieces of wood dropped into the ground, sticking out of the ground, maybe 2 feet, maybe 2.5 feet. If we were to begin to replace those with waste plastic, recycled plastic, we could burn up an awful lot of waste plastic. And because they're 6x6s, they're much larger. They're 3 times, they use up 3 times more material than a 2x4. So this is a significant way to get rid of large volumes of waste plastic. And the advantage, of course, is that if you think about Delaware and how much of it is lowland and wet, particularly in our state parks, it would be really advantageous to put plastic bollards in as opposed to a wooden bollard. They would last much longer. The maintenance would be much lower. So we'd actually end up saving. The cost of the material is about the same, maybe a little bit less for the plastic. And we've approached, by the way, the state about this idea as well as the county. And that's just that's 2 uses where 6x6s can be very significantly used. One in the retaining wall, and then the second would be in bollards for long drives and what have you.
Okay, my second question is about how much it costs. If I want to replace my deck, compared to putting down wood or plastic, what's the cost?
This is an interesting question, and one that I've actually been exploring with the University of Delaware right now. Many of you might know my daughter, Anna, who is a landscape architect over there. She is working on a project for up in Wilmington with a Head Start program, and they're looking to put in a decking material or decking area around a tree in one of the playgrounds. And they wanted to put in something that they could protect the tree roots and at the same time have a nice deck that would last for quite some time, wouldn't have potential splinters, wouldn't have some of those problems. So I began to work with DuPont to ask them to do some slip tests on the material to see what slippage would be like. We've tried to work that through a little bit. And then I started to look at the costs. And as we begin to get into the costs, we are pretty comparable, if not just a little bit less than what we are seeing for pressure treated lumber to go into the same situation. And the maintenance, of course, is much lower because it lasts for a much longer period of time.
So does it have the same strength? Can you make decks out of it? I mean, like a backyard deck, not just around a tree?
Yes, you can. One of the other tests that I've been looking at is the resiliency test or the deflection test. And again, I talked with DuPont about this, and I also talked with Jim in the shop. We began to look at what the deflection would be. It's our conclusion that if you use 16-inch centers on the material, you would not have any problem with flexing and warping. But you'd need to have a 16-inch center. We wouldn't recommend going to a 24-inch center on that.
Okay. All right. Thank you. Scott, I think you were next with your hand up. You want to unmute? I don't know whether you're muted or not. Go, Scott.
Yeah, can you hear me?
Yes.
Thank you, John, for the presentation. Thank you, Jill, for calling on me. You mentioned something, you started to ask one of the other people if they had clothing of a certain type,
Yes.
right? There are companies out there that are making clothing out of recycled water bottles, like pants, shirts, shoes, right? Yeah, is those, based on your knowledge, is that better or worse than using virgin material?
Well, again, we go back to the microfiber problem. No matter what type of fibers you're using, if they're polymer resins, they're going to be breaking off, and either in the washing machine or just as you brush against something. And as soon as you break off those microfibers, and remember, these are nanoparticles. These are very, very small. You're not going to see them. They're just going to be there, and they're going to get into the plasticized air, and you're going to end up breathing these things. So while I don't have any specific data on whether recycled plastic bottles or other recycled materials going into clothing would be good or bad, I can only report what the literature has told me, and that is when you have materials of that type, they will have fiber strands. The fiber strands will break off and can be potentially problematic. Did that answer your question, Scott?
Yeah, that answered it. Thank you.
Scott, I want to ask you a question. Are you going to be at the DMEC meeting on Wednesday night?
I was not aware of that,
Okay.
but
Maybe.
I can probably make the schedule work if I've got the details.
Well, I would like you and I to be able to take a call offline at some point to talk about DEVA and
Absolutely.
municipal parking issues with EVs.
Okay.
The Municipal Services Commission for the city of Newcastle, and I've been exploring this problem. So,
Okay. Yeah.
Sorry.
Very cool question. I've been asked that question. Judy, you've been jumping up and down with a question. Go ahead.
Yeah, I guess I don't, I wonder if we're getting a little bit sidetracked because for a few years now over at Lifelong Learning, we've been collecting plastic and proud of the fact that we're keeping a lot of things out of the landfill, which means out of the ocean. If you watch any of the ocean cleanup, you see what a glut of horrible plastics exist right now. So we don't have to work at cross purposes here. Keeping things out of the landfill to me is a major goal for all of us. Zero waste is really good, and by bringing these plastics to ecoplastics, we're not making a bigger problem, in my view, that we are helping with the existing glut of plastics that nobody wants. It does not preclude us looking, and indeed our group does look at reducing our own plastic that we have in our houses and looking for better products that don't require plastic containers. So we work in that problem at the same time. And I would like to hear from Dee about product recommendations, because then that's one of the things we try to do, is share that with a big population, that we have a platform to address these items or these concepts with Ollie throughout the state, actually. So that's thousands of people that we could share these ideas with. So I'm excited and didn't want to lose sight of the fact that whatever disadvantage there is in taking this waste product out of the landfill is a big plus. There, I think, whatever minuses you could find that it isn't perfect is small, is minuscule compared to what it's saving the environment. So I wouldn't mind having discussion more about that and hearing other opinions.
Dee, are you there to answer this?
I am. I guess, it's I'm sure you're aware, Judy, and others, there's like we don't recommend any specific products, but there are a growing number of products out there that would help you avoid the single-use plastic to begin with. And I mean, in the ideal world, if we actually did that, we would you're reducing the single-use plastic that can only be recycled once. So anyway, there's like, shampoo products that you can get as bar shampoo rather than in a plastic container. There's laundry detergent that you can get as sheets in a cardboard box rather than in a plastic container, that sort of thing. So we're all on this journey. I'm actually not as far along the journey probably as Cheryl is. Cheryl's a model for us all to aspire to. You'd be surprised at how much plastic comes through our household, I'm ashamed to say. But like even with plastic bags or plastic film, it's hard to avoid that right now. And no matter how hard you try, we still end up with it. So Plastic Products of Delaware is, a good solution for that kind of thing. We're just trying to continually reduce that. Now, John, I don't know if you guys, one good thing about your work, I'm supposing, maybe you can answer, is that a lot of or at least some of the plastic that you can take is not recyclable in your curbside bin. So your curbside bin right now, I think, only takes 2 different numbers of plastic, and I'm always forgetting which ones those are, 1 and 3 or 3 and 5, whatever they are. But Ecoplastics is able to take a much larger number of plastics that aren't normally recyclable in Delaware. So that's awesome. And so it's a journey that we're all on, just trying to kind of raise awareness about this issue. And now that we've banned plastic bags and we've banned styrofoam, that doesn't kick in till next year. But, we're just constantly trying to head in that direction of zero waste. Yeah, I don't think we'll ever get to zero waste, but we're all sort of heading in that direction, or trying to. We can talk more later, Judy.
Judy, you had something to say? I think you were shaking your head.
Yeah, like there is a limited plastic number. There's a 2s and 5s, and I believe, John, it's a 1 that go to ecoplastics. Not
2, 4, and 5 is what
2, 4, and 5. Yeah.
that's our preference. We
Yeah.
cannot do anything with one are basically plastic bottles. And the physics behind this is really pretty simple. The plastic that we take has a melting point of about 425 degrees. Actually, it's lower than that, but that's the temperature that we work with. And its solidification is in a range right there. If we begin to put in some of the plastic bottles, the temperature for melting point goes up. And it becomes incompatible if we commingle those together, because we end up with some materials melting at the proper point, and then we try and extrude them and we can't because other pieces are not melted properly. And it creates problems within the mix and within the simulated product, the simulated wood product. So we try and stick with 2, 4, and 5. We can take others, but that's our sweet spot, if you will. We cannot take number ones. It's just not our area at all. They have to get pulled out of the process.
So
But-
John, are number 1s bottles, you said? Like water bottles?
Yeah, plastic water bottles. I
Okay,
believe.
you can't take those?
No. And we can take
Interesting.
other bottles.
Because
but just
water bottles can go in your curbside.
Yes, they can. They can go in curbside, which is where I would love to see them go. Don't give them to us, because if
Mhm.
Right.
we get them mixed in, then we have to deal with it. And that
Right.
becomes
Mhm.
a little
Yeah.
bit more.
And the 1 has a market. The number 1s get where they're supposed to go
Yes, there is a
through
market.
curbside. Yeah.
There is a market for those, but the data out there suggests that separation is the big drawback to major recycling operations. It is very difficult to separate different types of plastic. Most of it's done by hand on these great big machines with conveyor belts, very labor intensive, and because of that, it's not very economical. It's not very efficient either. Which is one of the reasons why I think that staying smaller in this case is almost more advantageous. We would love to see an ecoplastics type facility in every county. To us, that would just make sense.
Yep.
Because then local individuals can deal with a disposal facility where they know what's going to happen to their waste. They can feel good about taking it someplace that it's going to get turned back into a usable product that is going to have less of an impact on the environment than if the material goes directly into the landfill. And I think that's probably the point where the discussion about getting rid of all plastic versus there are some plastics that we literally have to have in our world because of where we are in our world. I like the idea of getting rid of single-use plastics. I'm absolutely fully behind that. I think that's great. If we were to do that tomorrow, we still have landfills of this stuff that we have to deal with. And we can go mine landfills. We can go sweep the oceans and pull plastic out and have a stream of plastic for quite some time. We've got a mess on our hands. As the pictures of Newcastle demonstrated, there's a lot of small plastic material out there that we are not going to be able to recover. It's there. Unless someone comes up with a plastic magnet, I don't see how you can collect that stuff.
I liked your plastic eating bugs.
Or plastic eating bugs. But then we get back to it, with the hydrocarbon, the bugs actually use the carbon source in the hydrocarbon as a part of their energy. So they were breaking that down to nothing. I don't know whether plastic eating bugs would be able to do the same. I just don't know the technology well enough. I suspect that they would do some things, but I don't think they could break it all up.
Phil Smith, are you still there? You want to make your comment out loud?
Did you ask who?
Oh, I'll read it. Phil says, how about road cones? Seeing how much Delaware likes those cones along the side of the road.
Oh, big plastic Jersey barriers. They do make them out of plastic, but I wonder if you guys could make them.
That's a very big extrusion machine. And it's the problem with some of those types of materials for us, because we're a small operation, is the size of the mold that you need to have to make the material. and then the size of the extrusion machine that you need to fill that mold. Remember, plastic is cooling as it goes into the extrusion or through the extrusion machine into the mold. As it gets further and further into the mold, it gets cooler and cooler. If you have a humongous piece of plastic, you have to figure out some way to build that up over time. And the mold itself, our molds are made out of aluminum on the inside, and then they're jacketed with steel. And we jacket them with steel because the material, if it doesn't cool properly, if it cools too quickly or too slowly, it will get bubbles in it or imperfections. So we have to put aluminum in there first, and then if we don't jacket that again with steel, not only do we get the imperfections, but we'll get bends because of the cooling of just the aluminum without that shielded stiff steel around the outside of it. A typical mold for us might cost $800 or $900.
So you have to recoup that money.
Yes.
You
Too
can't
bad.
do a lot of, yeah. Thank you. Ruth Ann, do you have another comment? You have your hand up here?
Yes, can you hear me okay?
Yes.
Okay. I put Beth Terry's website in the chat room because Beth Terry qualifies as a citizen of the Lenape Indian Tribe of Delaware, which is our local state recognized tribe. They have the highest Native Americans per capita of any federal census district off the reservation in all of North America, and that's without any education. So it's a really amazing opportunity to work with people who once knew that all life on Earth is sacred. Meanwhile, Beth Terry goes and gets a normal job and moves to the suburbs of Maryland, and she starts an organization called My Plastic Free Life. And she wrote a book, My Plastic Free Life. And she has become a guru, and she has a big following. So if anybody out there is interested in learning more, she recommends different products, and she's super dedicated to living a plastic-free life. Now, setting that aside, the community that is the backbone of our tribal census district is a very disadvantaged community. And I'm really, really intrigued by the idea of starting something with you in that community. And just off the top of my head, I wondered, have you ever done anything with like the Swedish composting toilet design? I know somebody in Delaware is designing them, a local fabricator, but I don't know if they're using recycled plastic. And it seems like at least what's above the surface, above the floor, could be recycled plastic, and we could enter into that world of the Swedish composting toilet. And I say Swedish because that's the first name I heard it by. There might be other names now, but I just was curious. And so please let me know if you've ever heard of such a thing.
I've never heard of using recycled plastic, using the process that we use to do that. Remember, we're an extrusion company. We're not a molding company. I say extrusion molding, but basically we push hot material into a shape that is pretty easy to push the material into. In order to mold plastic, you actually have to have various shapes, and it takes a little bit of a different machining and certainly mold to create those shapes. We don't do that. That gets to be a little bit more specific than what we're capable of doing. But it's a good idea. It's something that could be looked into. I'm sure someone can figure out a machine that could push melted plastic into that kind of a mold pretty easily, and then figure out how to break it apart. If you think about the legs on our benches, that is about the most sophisticated mold that we have.
Thank you so much. And thank you for giving us the beautiful gift of Anna Wick. She has been such a blessing to our Lenape Forest Garden and our forestry training program. I just honor her so much. Thank you so much.
Well, thank you.
Thank you.
Dads love to hear that stuff.
We have one, I think one more question. Jeanette, did you have your hand up? I have a couple more questions.
Well,
Robinson?
yes, I did. I'll try to be brief. I am very far from any kind of business acumen. But I'm wondering like about funding for ecoplastics being a nonprofit. How can we increase that? Where does it come from? And the other thing is we need to really join together with some more advocacy groups to get funding. I'm thinking about the more things you can make that you already make, because you already have the facilities like park benches. I live in the city where there are a lot of little parks. It would be great if they had more benches. And how could we work together to work not only with the Parks Department of Parks and Recreation, but also with our legislators, both county, D, and our senators and representatives, to get this kind of thing done. It would be simple and it would take care of a lot of the plastic waste. So I'm not sure how to start, but there should be legislation written, etc. Do you have any ideas about who to contact about that?
Guys, I have to step away for just a minute. My dog is outside barking. So if you could answer that question and then Cheryl, and I'll be right back.
Okay. As a matter of fact, green drinks presentations are a really good way to begin to bridge that gap. The speaker last month was Ray Bivens from the Delaware State Parks. After the presentation that he made, he and I had a chance to get together and talk a little bit about what was happening in the state parks. And I suggested to him that we had the capability of doing bollards. He immediately recognized the value of that, and he turned me over to David Jones, I believe it is, within the maintenance department at state parks. And we've been talking with them about bollards. And that discussion led to another discussion about trail markers, those little posts that they put in the ground to direct you on which trail you should be taking. So every time we have a little bit of an outreach just like this, we get to mingle and meet with other people within the state government or the county government, and we're able to push this effort a little bit further along. Again, the bigger the product that we can push out, and products that are less labor intensive, those are better for us. That doesn't mean that they're the best thing for someone else who wants to come in and do a Swedish toilet. I mean, that could be a great application, and the Swedish toilet folks might want to just set up their own sub company that brings in waste plastic material and runs it through a chipper and an extruder and molds it into whatever form that they might need. It could be a niche market for them. But it's all about discussion, and it's all about what we can do as individuals to reach out to the community, reach out to the legislators, let them know what's going on. I had a conversation with Matt Meyer about this, and Matt is thrilled with what we're doing at Ecoplastics. And I came up with the same question for him. Can we do more for the county parks? And so we're now talking with the county parks about the concept of bollards. The trustees of Newcastle Common, right here in my hometown, I've talked with them about putting a curb retaining wall in along the Fort Casimir walkway, and they're very interested in doing that. There's another 2 tons of plastic material that could go out the door. It's all a matter of networking. And what I would request of all of you is as you see opportunities for us to network, please just pick up the phone, call me, or call Ecoplastics and talk to Cheryl or Jim, and we'll explore them as quickly as we can. The economics question, that's very difficult to deal with because the equipment that we use is older. We bought it used, and that gives it one price. It's very difficult to find packages of chippers, extruders that do what we do. And that's what I've been looking for the last probably 6 months. I've been looking for one company that could build a package unit that would have all of the little components that we need, and then set it up, and it could be purchased by a group that wants to come in and just start a recycling operation like we have. Ecoplastics is more than willing to take any business individual who wants to get involved with this. and we will train them. We'll sit down and show them what we do, how we do it, what they need to know about it, what the market is, what the economics of it are. That's part of our mission. So we would be happy to do that, but to this point, we've not seen anybody coming in who was really that interested.
Jenna, I might add to John, we should probably talk because one of the things we're looking at is DENREC is actually you heard John talk about the regulatory battles and limits, and he didn't, I don't think, even mention the fees required.
Okay.
So that's something we've been battling the same sort of battle for community composting, and it's something we might work together on because DENREC last year actually had a bill to increase fees for this type of recycling, the whole range of all kinds of recycling programs, and which fall under the category of waste. And I think we really need to change the paradigm of what is considered waste versus, what is recyclable and reusable. And so anyway, John, we should talk because the bill they had last year died, but because a lot of people there was outcry about what it was. But DENREC's trying to increase the fees, and we need to make sure that the barriers to this type of good program are reduced, not increased.
Let's talk.
Yeah.
I'm going to chime in and say, yes, absolutely. In fact, let's talk with Matt Meyer. Let's have a good conversation.
Yeah. Because
I also wanted to suggest, John, I don't know if you guys have thought about whether or not your material could be used for 3D printing.
I have. I will tell you, I have explored this market. We had a market survey done for us by Goldie Beacon at one point, and their students came in and put together a nice little business market survey. And one of the products that they suggested in that, when I read it, I was kind of surprised, was 3D printers. The drawback, we commingle plastic. We do not have pure streams of plastic. For most 3D printers, you really need a fairly pure and specific plastic so it has a consistent melting point. That's how the machines run. You have to melt the strings of plastic into that, and then they have to solidify at the proper speeds and times. So it really is not a good niche for us because of the specificity of the plastic that has to go into a 3D printer. Now, there are some big houses that are now being made using 3D printers. I think they're using not plastic, but I think they're using cement and concrete as their material. I've seen those. There might be applications for bigger products that you could run through a bigger kind of a 3D printer, but not the small ones that you're probably thinking about.
Okay.
Is that your hand up, Cheryl, or did you have?
That was it.
How to raise my hand. Can I ask a question?
Yes, there you go, Ann.
I wonder, are there particular products that we ought to be focused on to use that have recycled the 2, 4, and 5 plastic, and others that don't use it? I mean, how do we sort of reshape the market about what people buy? Is that possible to even think about? I don't know.
I would say that would be a very difficult thing to do.
Right.
Because we're working against the economics of the business world. Right. This is not a problem that they focus on. They're focusing more on getting their product out the door in a form that is inexpensive for them, but it maintains the integrity of the product.
So, but maybe bad for the environment.
I'm biting my tongue.
It's an uphill battle. There's no question about it. But
it's a battle that environmentalists have been fighting for years, and that's the nature of it. Is that you're fighting business and you're fighting production, and it's a very difficult battle. We made a lot of inroads with plastic, and then we suddenly see this shift from the manufacturing world, the business world, where they said, oh yeah, recycling is a really good idea. Let's push that. And now we find out later that it was, in some senses, an attempt by industry to force the problem back on the consumer rather than having a solution on how they were going to deal with this. They just pushed the problem back to the consumer and put little
Bingo.
what?
Yes, bingo.
Bingo.
Yeah. So-
Susan, did you have your hand up here?
I do. At Bali, well, for Earth Day, but other times we can have a demonstration where we show products and the nice big jug of Tide that's also difficult to carry. You can get this size box with the detergent tissues in, and we show numerous things that we can save on not using plastic containers.
That's great. Is there some way to get that broadcast? Does Ollie do any broadcasting of any of this information?
Not yet.
Well, let's make that happen.
Judy, you're shaking your head up, yes?
Yeah, well, it's always our plan, because we do have various platforms and through the Lifelong Learning Center. So and it would be really fun to explore and exploit as many of those as we can as we come up with products that we try within our class. And then when we like them, we're not shy about saying, use this, not this. So we do that. But the potential of influencing 1,000 senior citizens is real. Like we can do that. We have the potential of doing that. And it's the plan.
So
You
we
should
just
come
we
to
got a
our,
little advertisement from Susan.
Judy, you should bring that roadshow to our youth summit, which is 1,000 high school students in February, and have a table there. That would be awesome.
Absolutely, we would do that. You invite us, we will come.
And I'm thinking too, when it comes to getting some bills in front of the legislature or getting some bills out of the legislature, you know, a lot of people know who their elected officials are in the state and can make a lot of phone calls.
These are my detergent sheets here. Not even as big as my hand.
Yeah.
And when you travel, they're nice to take with you too this way.
Very cool. Do we have any more questions or comments or thoughts along the way? Carol, is that a comment or okay? Just to say that goodbye. I can read your lips. So John, thank you. That is just fabulous. Good learning. I always like the history of stuff. And I think that graph that shows how it starts and, you know, and the graduate said plastic, and then we're going to be taken over by plastic. And Anne, thank you very much for bringing John to the fore here. I'm always tickled that, you know, people comment. It's like, oh, everybody knows you anyway. So it's wonderful. So let me do a brief advertisement for our next Green Drinks, which is October 21st. And it is Carrie, I'm not quite sure how to say her name, Stover, Stoever. And she is the chief strategist for the Partnerships and Policy for Planetary Boundary Initiatives, which was co-founded by John Rockstrom, who's the director of the Potsdam Institute, sounds very impressive, for the Climate Impacts Research and Planetary Guardian. And so we'll put that all out to you in an email. She is the daughter of one of the active members of Indivisible Highlands and Beyond. So that is how we often get our speakers. Phil Scott, looking at you, Scott Phillips, I'm sorry, I'll be back with you soon. Hi, Ruth Ann. So ideas are accepted for speakers coming up. And so if you have thoughts and ideas, please share them with Dee and me. So we're done with our recording. So all of you, thank you very much for joining, and we will see you on the next third Monday in October. Thanks so much.
John, thank you. Go Eagles. Everybody's watching Monday Night Football.
Time to
And
get-
we push
Thank you
the
so much,
lead
John.
button.
Good.